Hello, everyone, and welcome. I'm Allan Jude, your host for today's session. Whether you're joining us live or watching the recording, we really appreciate your time. For those who are new to Klara, we're a team of open source experts specializing in ZFS and FreeBSD and helping companies worldwide optimize their systems and tackle complex technical challenges. So you can talk to us if you're looking to re-architect your storage pool, figure out how to squeeze more performance out of ZFS, or if you want to actually develop new features for ZFS or FreeBSD. But today we're here for a webinar. Today's session, Fast Dedup with ZFS, Smarter Storage for Modern Workloads. We'll talk about how Fast Dedup reduces redundant data at scale, where it delivers the most value, some implementation tips and integration best practices, and why ZFS continues to lead as far as storage performance, resiliency, and transparency. Throughout the session today, feel free to drop your questions in the chat or the Q&A, and we'll be monitoring both and answering some questions live. And joining us today, we'll have Kris Moore from TrueNAS, and we'll get to introductions in just a second. So our agenda for today, I'll start by introducing the speakers in just a second, and then we'll start talking about how you can use ZFS Fast Dedup to reduce the amount of data you have to store. Then we'll get into some use cases for deduplication where it really shines, and then implementation tips on how to make the most out of it and the kind of do's and don'ts. And then finally, talking about just why ZFS is the right solution in general. And then finally, some summaries and takeaway. And we'll get to some more of the questions at the end, but feel free to ask questions as we go. And actually, first question from David Puckett asks, is this TrueNAS centric? No, Fast Dedup is a general part of OpenZFS and is available on all the operating systems supported by OpenZFS. So quickly introducing myself, I'm Allan Jude. I'm the principal solution architect and co-founder of Klara, and I'm joined today by Kris Moore.
Hey, glad to be here today, Alan. This is good. Long time coming. I'm the senior vice president of engineering here on the TrueNAS side.
Yeah, Kris and I used to do a podcast together about a dozen years ago. So it's funny to be back in the same place with the same microphones as a dozen years ago.
They still work. They still work.
Yeah, so moving right into it, I'll talk a bit about what Fast Dedup is and how it works, and how you can use it to reduce your total cost of ownership. So in general, online deduplication, which means doing it as the data is coming in rather than after the fact, is the process of finding identical bits of data, and instead of storing the two or multiple different copies of them, when you write the second and third and nth copy, to actually just have a reference to the existing copy of the data. And so that allows you to store multiple copies of the same data in separate files or different VMs or different containers without having to make the extra space, but without having to manually manage those either. So ZFS will take care of it all automatically. The way ZFS does this is by using the checksums that ZFS is already calculating and keeping a big list of basically every checksum it's ever seen. And if it sees the same checksum a second time, it can say, hey, I already have that block. I will now add it to my list and say, all right, I'm two different files are using this block. So now when one of those files deletes that block, instead of it becoming free space, we say, well, we'll have to keep it because somebody else is still using it. And only once the number of people using it gets to 0 does it actually become free space. And so ZFS has had this feature for decades now, but it always had performance problems because keeping that giant list of every hash you've ever seen was a relatively big list and could use a lot of memory and cause problems if you didn't have enough memory to fit it. But also the way it was updated. Every time we did a transaction group, ZFS had to update that table, including all the indirect blocks to find it. And because the table is sorted by the hash, but a strong cryptographic hash is random, it meant if you wrote a bunch of blocks in a file, they would be in very different places in the list. And so it was a lot of work to go and update that list or even just search it every time.
Yeah, it's very computationally heavy.
Yeah. And if that list couldn't be kept in memory, it was also IO heavy. And that's where you ran into this performance cliff in ZFS, where if the dedupe table was suddenly so big that it couldn't all be cached in memory, it meant that it would have to go and read a chunk from disk, and then your performance would go from pretty good to terrible very quickly.
Hmm. Yeah, this is one of the things that gave the original dedupe implementation in ZFS kind of a not so great reputation. A lot of people cautioned, don't use it. There was a lot of real high requirements around where it was safe to turn on. So being able to put some of those things to rest here in 2025 is kind of a big deal and a long time coming.
Yeah. So Klara, in partnership with IX Systems, developed Fast Dedup, which aims to solve some of these problems. The first big thing was the log dedupe feature. So instead of having to update that giant table at the end of each transaction group, which can be every 3 to 5 seconds, instead ZFS would just append to a log that, oh, this hash went up by one, this hash went down by one. And then in the background, it could coalesce that log and apply updates in bulk. And in particular, it would do this by sorting it alphabetically so that all the blocks that started with 00 got updated at
Hmm.
once. So you only had to update the metadata block one time instead of hundreds of times. And this greatly reduced the number of IOPS required for the kind of housekeeping of dedupe. And then it came with another slew of features that really made the difference. The first one is the dedupe quota. This allows you to limit the amount of data that will be deduped. So you can set a maximum size to the dedupe table to make sure that it will always fit in memory
Hmm.
or on a dedicated device, right? If you're going to have a dedupe VDEV that's going to hold the dedupe table, then you want to make sure that you don't ever get your dedupe table big enough that it spills over and is stored on the slower devices, where again, you might introduce one of those performance cliffs we just talked about.
Hmm.
So this quota allows you to basically say when the dedupe table gets this big, stop deduping new blocks to avoid spilling over into unfun territory.
This was probably one of the most critical features for us on the TrueNAS side, Alan. For enterprise, it's about the consistency of performance over time. And that was what made dedupe so tricky in the past to recommend, is because you couldn't guarantee that consistency. You'd hit a certain point and again fall off the cliff. But these days, being able to say, what kind of performance, your IOP should stay in this range, and we're going to do our best to ensure it doesn't have any sort of jumpiness towards the end of life.
Yeah, and where it would perform great at first and then get terrible later on was just
Hmm.
not a good way to be able to build or plan out a system.
Yep.
And then we added the preload feature. So another thing that some customers found is that when they were using dedupe, after they had to restart the system, every time they went to write a block, they'd have to wait an extra amount of time while ZFS did random reads of the dedupe table to find that range involving the new hash they were writing to see if it was in the dedupe table or not, and then add it if not. Uh, and so this could mean for the first couple of days after a reboot, the system would perform poorly. So this preload feature allows, as part of booting up, to just automatically load that whole table in and get performance restored in a couple of minutes instead of a couple of days. And it really makes a big difference for
Hmm.
getting that consistency of performance again, especially when you have a cold cache.
Hmm.
But I think the big thing that made fast dedupe scale is the dedupe prune feature.
Hmm.
So in dedupe, there are actually two lists in the DDT. The one of every block we've ever seen only one time, and then the other list of all the blocks that actually have two or more copies. And so it turns out that while ZFS did depend on having the list of every block it had ever seen, it's not strictly required. And so what we can do is when we're getting close to that dedupe quota, where we're going to have to disable dedupe if we uh, don't remove some stuff, we can find the oldest blocks that have never deduped
Hmm.
and remove those. So files you wrote, months ago, and in all that time they've never gotten a second copy, are less likely to get a second copy. Whereas the files you're going to write right now, it turns out maybe you're going to write a second copy of those in a couple of minutes when you spin up another container or whatever. And so prune allows you to remove those singletons from the list to make room in the DDT for new blocks. So that way you can always allow dedupe to continue instead of having to just switch dedupe off once it got full.
Yeah, this has been really critical for our customers, Alan, because there's even in the most dedupable of scenarios, there's just a certain amount of blocks that are just going to never be deduped for one reason or another, and just keeping those in the memory and eating up space that we could use for more effective use elsewhere was just not optimal. So getting this in addition to the quota was huge. Again, this is some of the stuff that took the dedupe old system and into something new that makes it viable for so many more workloads that customers can use and appreciate and rely on with consistency.
Exactly. Now we have a live question from Paul. Paul asks regarding preload, does the import of the pool at boot wait for the preload, or does the preload happen asynchronously in the background? And so it happens asynchronously. There's a command to trigger it, and then you can use zpool wait or a flag to the preload command to have that command not return until it's done. But it happens in the background, so your system can come up and you can start reading files and doing everything while the preload is happening in the background. But there is a way to wait for it if you want to, in like a HA system or something, not want to start, uh, you know, putting heavy load on the system until it's done. But it is completely in the background and doesn't block boot up or make things take longer.
So Paul was on the TrueNAS side. So in our case, Paul, we typically want to prioritize bringing the system back online to get services back in the ready state and not leave clients hanging. So in that case, we would be loading asynchronously in the background by default.
Yep. And then a new feature that landed upstream and will be coming out in the next release of OpenZFS, which I think is this fall, is the new pacing improvements. So we further enhanced Fast Dedup so that when we're processing that log in the background, we improve the way it decides how fast to do that. In particular, when the system was more idle, it was not getting through that log as quickly as it could have. And with these changes, it will now take advantage of idle time to get through all that log quickly, but at the same time, not slow down your actual workload at the same time. And so what's interesting there is looking at the performance of Fast Dedup. So on this chart, in black, we have the performance of a system with dedupe disabled. In purple, we have the new Fast Dedup, and the yellow dotted line at the bottom is the old legacy dedupe. Now, this test was done specifically with entirely random data by a benchmarking tool, so none of this data actually deduplicated. So this is the worst possible case. If you actually had data that did deduplicate, there'd be a blue line above the black one going even faster because any data you write that you've written before will take almost no time to write because you're not actually writing it. You're just recording that, hey, there's a second copy of this block from over here. And so it can actually let you get more performance out of the disk than. But the big thing you can see here is that with legacy dedupe, as you wrote more and more data, as that's the x-axis here, this performance went down and down and down and down. And this is even with a relatively small amount of data, even just 320 gigs of 8K blocks, which was, it's small blocks on purpose to make the table be bigger. But you can see that the performance drops very, very quickly to like a third of what it was at the beginning of dedupe. And importantly, like 1/8 of what it was without dedupe. Whereas Fast Dedup mostly can keep up because it is logging updates in a more asynchronous way instead of having to block every time you're trying to do this. So then we get into the criteria of what makes a good workload for dedupe. Because as Kris will explain, dedupe isn't the answer for everything.
Absolutely. Say there's a tool for every kind of problem, right? So fast dedupe, again, there's no magic to it. There's no free lunch either. You're doing more work. There's computational things that have to be done. And you need to make sure that's going to fit with whatever your particular workload is, your customer data. Again, it's not magic. So if you're writing a bunch of archive files and there are no dedupable blocks, well, you shouldn't be surprised that you don't see your dedupe ratio goes up because, again, there's no dedupable blocks. If you're encrypting everything, well, by nature, encryption is going to make them all not duplicate blocks. You're not going to see dedupability. But for use cases where you do have a highly dedupable data set, again, there's no real limit or rule of thumb. It really depends entirely on how much data you're going to throw at it. If you're cloning VMs all day and the base image of those VMs is 90% identical, you're going to get a great dedupe ratio.
Yeah, and so one of the biggest things, especially the VM case that Kris just mentioned, is alignment. So if you're creating a bunch of VMs, and even if they're going to have the same files inside, you have to make sure that the file system inside the VM is tuned to start files on a boundary that is going to match with what ZFS is doing in the background underneath the VM, so that the beginning of the file in VM A and the beginning of the same file in VM B start on a record boundary in ZFS, because then it will notice, hey, these two are the same. But if they start on different boundaries, then some other file is going to be the first half of that record, and ZFS is going to say, well, those aren't the same file. And so getting that alignment right is the key to getting dedupe in VMs to work. And so it requires tuning the file system inside the VM to make it align with what ZFS is expecting on the outside.
Absolutely. Then the next thing we had, of course, is suitable hardware, Allan. Again, sizing matters here. How much data do you plan on ingesting? How big is your pool going to be? Or how big is the data set that you're going to turn dedupe on? And how much RAM do you have to hold those tables before you get into I'm getting quota limited and having to start pruning blocks? So again, it's important to kind of know what your use case is going on up front. You wouldn't just turn this on and YOLO it and say, oh, we'll just see what happens. Plan accordingly, think accordingly, understand your data first.
Yeah, you really want to plan and decide how big you want to set your dedupe quota to. If it's too small, then you're going to hit that limit and not get the advantage of dedupe. Or that actually even fits into a question that we just got live from Masood. He says, if a hash for a file didn't dedupe for a while and got pruned, what happens when we do create a second copy of that file? So because that hash isn't in the dedupe table, we would add the hash back to the dedupe table for the new copy of the file. So it wouldn't dedupe. It would be as if that file was written for that hash was written for the first time ever. So you would actually have two copies. If you then wrote a third copy before the second one got pruned again, it would dedupe. But yeah, we can't retroactively know about the file that didn't dedupe for so long that we pruned it.
Let's say we had a related question in chat, Alan, about what happens with files or blocks that are on disk already before you turn dedupe on. And I was curious, you saw the recent ZFS rewrite command landed. I'm wondering if that would be applicable in this situation.
Yeah, so if you turn dedupe on, then the table is empty, and so it won't know about the previous copies. But as Kris mentioned, if you used the new rewrite command to rewrite all the data, when it rewrites the second block, it will again see that hash and actually enable dedupe on it.
Dedupe it, yeah.
And so that will dedupe it for you. Exactly.
For those who haven't taken a look at that command yet, it's just a nice way to do it inside of ZFS. In ye olden days, we all used to have like Python or Bash scripts that would go and like make a copy or move a file or whatever to kind of force it to put it on a new VDEV or go through the dedupe process again. But the rewrite just kind of does it inline, lets ZFS do the lift.
Yep. And then the last thing is that there's no upgrade path from legacy dedupe to fast dedupe. That wasn't really judged to be very useful. So it's best to design for the use of fast dedupe from the start, because you want to pick the right record size to have the right trade-off between the amount of metadata and the amount of dedupe, but also decide how data is going to be written. In particular, dedupe is compatible with the ZFS native encryption, but if data is encrypted by your application, then when ZFS sees it, it only sees the encrypted version, and it won't know that two blocks were the same thing because they will encrypt differently, right? If your encryption dedupes, there's not very good encryption.
That's right. Maybe you should switch algorithms.
Yeah, for sure. So moving on, we're going to talk a bit more about when to deploy dedupe and what some of the highest impact use cases are. Now that we know what the criteria are, what are some good use cases? As we talked about, virtualization, although there are some caveats there about making sure things are aligned so that ZFS will actually detect the duplicate data. And also, it depends on what's in your VMs, how likely it is that you will actually get useful amounts of dedupe out of it.
Yeah, for example, customers we may have seen in the field where they're deploying a VM, but then they're also deploying a very similar workload inside the VM and copying a lot of data redundantly to these different VMs for processing. You can save some on the storage side there as well.
Yeah. But one of the places where it really shines is with containers. Because containers are going to use a native ZFS file system, ZFS will know where a file starts and ends. And so if you actually have the same file in multiple containers, ZFS will be able to detect that and apply deduplication and save possibly a lot of space. We've seen customers with hundreds or thousands of containers on a machine, and even with really stripped down uh, operating systems on the inside of those containers, there's still a bunch of files that are in every container.
Yeah, that makes total sense. And I know one we had talked about too, another use case maybe people don't think about typically is CI/CD. So for example, here on the TrueNAS side, we run Jenkins everywhere. And Jenkins is just producing ISOs left and right every hour, however many of them we're producing, right? As pull requests are coming in. Well, guess what? Those ISOs are 99% the same every single time. And we're having to artifact and store them all because, again, you got to have the whole file highly dedupable. So there's definitely a use case if you're running any kind of CI CD pipeline. And dedupe may be something interesting for you, especially if you're retaining a lot of those artifacts, which, we'll do 30 days typically.
Yeah, we worked with a video game studio that makes like AAA games you've heard of probably, and they built their CI/CD system, and because they could take advantage of ZFS dedupe, they could build it with all NVMe drives. Whereas if they didn't have dedupe, they would have had to use slower hard drives, and their CI/CD system wouldn't have been as fast. But because, especially with a video game, there were like 300 gigabytes of uncompressed textures and other assets that
Hmm.
went into each build of the game, and they're kicking these off like constantly.
Oh, yeah.
And getting 8-to-1 dedupe on those 300 gigs of art assets meant they could fit all their CI on a bunch of NVMe drives, whereas without that dedupe, they would have had to go to hard drives, and their CI would have been many, many, many times slower.
Hmm. Or then you have to make trade-offs of, well, I can't artifact them as long, and I'm deleting them weekly or daily, depending on how many you're generating. But engineers like to keep their stuff around for a while, so it's nice to have
Yeah,
that
or you're doing
ability.
contortions to try to, oh well, each VM will like mount the shared assets over
Mm,
a Samba share or something, and it just gets very
it gets
fragile and
messy.
breaky. Yeah,
Yeah,
whereas
that gets messy quick.
just using dedupe really meant that they were able to basically be able to use faster hardware than they would otherwise be able to because they were managing to save so much of the duplicate space.
Mhm.
And that really gets into, when you have the right use case where dedupe is going to save a lot of space, then it means that you may be able to buy more performant media, or just otherwise take advantage of the fact that you're not having to use as much space.
Absolutely. So the economic equation is super important on the buyer side. So again, if you can take that dollar and put it towards faster media, there's benefits to that as well.
Yep. Yeah, in the end, deduplication isn't just about saving space, it's about unlocking the performance and scalability without breaking the budget, right? Again, because they could store the same amount of logical data in less physical space, it meant they could have NVMe drives instead of having to buy SSDs or hard drives. And that meant that in the same budget, they could get a lot more performance.
So maybe one of the things we should have mentioned, Alan, is it's not a trade-off between dedupe and compression.
Yes, that's actually one of the best practices that we get to
Oh, okay.
here. In particular, yeah, as we mentioned for the VM workload, you really need to focus on aligning that record size so that files start at a known offset that matches the ZFS record, and that allows ZFS to find the most duplicates and deal with them. But the other trade off there is the ZFS record size. A larger record size might not dedupe as much because, if the a file's only 64K, but the block under it is larger, then if it's a file, ZFS will do the right thing. But if it's, a big VM image or
Hmm.
something, then ZFS won't know where a file starts and ends. They're just blocks. And it means that uh, even if there is two identical files, the file next to them might not be identical, and so the block won't be identical, and ZFS won't be able to dedupe. So if you use a smaller record size, you can find those duplicate blocks more easily because there's less chance of bleeding over from other data. But it means you have to store more entries in that dedupe table, which means it takes more memory on your dedupe VDEV and more uh, RAM in the system for the same amount of actual data. But it might give you a better dedupe ratio. And so
Hmm.
finding the right trade-off for your workload requires knowing a bit about your workload and what is the native cluster size of the file system that you're writing in the VM, or what are the file sizes you're actually putting in the containers to decide where the right trade-off is to get the most efficient by not having way more metadata than you need, but the best dedupe ratio for your workload.
And then, as we mentioned again, keep your compression enabled, maximize your benefits here. As I said, it's not a trade-off. You don't have to pick between one and the other. And you want that fallback of, I have non-deduplicable data, but I can still squeeze a little bit extra out of it by keeping the compression on, which usually doesn't
Yeah.
have a high cost anyway because of ZFS's intelligent way it deals with compression and tasting a block before it decides if it's going to go all the way.
Yeah, in particular, the ZFS transparent compression can also do things like, hey, it turns out this VM image is sparse. So there's a big chunk of it that are just zero. But if somebody created a file and then removed it and we don't have trim or whatever, then there might be this little bit in there that makes that block unique, even though it doesn't contain anything. And if ZFS compression can squeeze all the zeros in that down, then you can get that much more space savings on top of it. So because the compression in ZFS is reproducible, meaning the same input will compress the same each time, it means that you can use compression together with deduplication to shrink the block as much as you can and still dedupe it.
Mhm.
And getting the benefits of both can really make a big difference in how much you're saving. And
For this
then
last one
there's
here, I think we're
BRT.
going to have to explain BRT,
Yes.
this whole other dedupe animal that's different but similar.
Yeah. So especially before fast dedupe, uh, there was demand sometimes for people where it's like, I have this one file and I want to make a whole copy of it, but I don't want to enable dedupe where I have to keep track of every block I've ever seen in every file. So
Mhm.
BRT, or block reference tree, uh, also known as reflinks in other file systems and in the command line on Linux, basically allows you to explicitly duplicate a file. So instead of actually using dedupe, even fast dedupe, BRT has its own table where it just says, hey, this block on disk is also used by this other file. So it
Mhm.
allows you to purposely duplicate an entire file or a range of a file. And so it means when you want to copy a file from here to there, instead of having to actually copy the data, we can just basically note it as a duplicate,
Yeah.
similar to dedupe, but a little bit different. And in particular, the iSCSI, Daemon, and Samba all support what's called server-side offload. So
Mhm.
if you're, on a Windows client machine and you're copying a file from the server to another place on the server, it can use BRT in the background to make a copy of that file without having to copy any data. And so it will copy really, really fast.
We had an interesting case on the TrueNAS side when we first flipped this on, and somebody updated without knowing this was going on in the background, and they had an interesting forum post. So I have a 1 gig connection here to my TrueNAS, and I'm copying a file in Windows, and it says I'm copying at 100 gigabit speeds. Like, how is that? What is going on here? He thought it was a bug. But no, it's doing the server side copy. It's just not actually making a copy of all the data. It's the pointers essentially.
Yeah, and it's not sending it back and forth over the network needlessly either.
Hmm.
And so that server-side acceleration can make a really big difference on workloads that do a lot of that, which can really apply to things like CI/CD pipelines and so on,
Hmm.
where you're going to be purposely copying a whole bunch of data in order to stand something up, and suddenly that's much, much faster than it was before.
Absolutely. Or again, for virtualization, we have a lot of folks who use virtualization on NFS, for example, and are making copies of files for their VDIs. That could be beneficial. We should probably mention, Alan, that BRT doesn't compete necessarily with the dedupe tables in RAM as well. So it's not a, oh, I need to go turn this one off, turn on the other kind of thing.
Yeah. So one of the main advantages to BRT is the table is only ever as big as the files you purposely duplicated. And it was designed to have a much smaller table since it doesn't need to track things like the hash of the data. It just has, these blocks on disk are used in multiple places, and that's it. It's
Hmm.
a much smaller table and is bounded by how often you use it instead of dedupe, which has to kind of be always on and running in the background. But BRT requires that you know that you want to make an exact copy of a file, whereas online dedupe is about detecting the cases where you didn't actually know or don't
Yeah.
control that you're making a copy of the same data.
So this is an important point, I guess a little pro tip for people who are trying these out. So on the customer side, we'll see people when they're on Windows, for example, they'll send a bug report in. Oh, it's not working. I'm not seeing anything get deduped, or I'm not seeing the server side offload. And it's because they're not using, say, Windows Explorer. They're using a third party tool to make copies like Robocopy or something in the background, which isn't issuing the right commands to the Samba side to say, I'd like to make a copy of this file and do a proper copy file range. Instead, it's actually copying block by block
Yeah, it's
from the
just
client
reading and
side.
writing.
Yeah. So in those cases, we'll usually tell folks, we'll go test it with regular Windows Explorer or Finder on Mac and make sure it still all works. If it's working great there, wonderful. Then we know it's more of a tool problem. So again, pay attention to which tools you're using because not all clients will do it the right way. This is where you would turn on dedupe though, and dedupe would say, well, I don't care if the client's telling me to do this explicitly. I'm still deduping in the background every block that comes in.
So we have another question here from Masood. He says, I saw on a previous slide that data has to be unencrypted to be deduplicated. So to clarify, it has to be unencrypted when it comes from the application. ZFS encryption works with dedupe, just not if the application's encrypting the files before it writes it to ZFS, then ZFS can't see the data to tell that it's a duplicate. But if you're using ZFS encryption, it works correctly with dedupe. Okay, moving on. The last one we have is just why ZFS continues to lead and why ZFS is the right answer. So the first, obviously, is reliability, right? ZFS was designed from the beginning to be a reliable file system. ZFS cares more about that than the performance and the dedupe and all these other features. The core of ZFS is making sure that when you write data, that ZFS will be able to give you back exactly that data or an error, never the wrong data.
Mm-hmm. I guess it's the whole principle of we don't trust the hardware at the end of the day.
Yeah. And that's why, for example, ZFS has RAID Z3, the triple parity RAID, which, Adam Leventhal had to invent new math in order to actually make that happen. But it means that you can actually have 3 drives in the same VDEV fail and still be able to reconstruct all the data and continue to perform. Now, RAID is not a backup, but it does mean that you can reconstruct blocks and keep things going. And that's really where ZFS is a lot different than any kind of hardware RAID or most other types of storage is the end-to-end checksums. The fact that every block in its metadata has the checksum of the data as it was written to disk means that when it reads it back, it can verify that the hardware gave back the same data. But it also means in the case of a RAID, if a disk is suspect, we can actually, by reading and trying the different combinations, figure out which disk was the one that had the wrong data and correct it and keep track and notice, hey, this one disk keeps giving us the wrong data. Maybe you should replace it. Whereas hardware RAID might not ever know and just feed that junk data back to your application and cause you no end of trouble.
Mm-hmm.
The next big selling feature, obviously, is the flexibility. The fact that you have options on how to lay out your disks and the fact that you can have special VDEVs and, offload your dedupe to some NVMe drives while still using whatever less expensive storage you're going to be using for the main storage and all of that. But also the fact that you can create separate file systems, right? ZFS datasets, and each one can be tuned differently. So you can have a bunch of storage with dedupe set up for your containers and different setup with, say, a larger record size for your generic file server setup, and that way you can make different choices for that dedupe trade-off based on different workloads, or decide I know nothing in this data set is going to be deduped, so I won't enable dedupe on this data set, and that way you're not populating that DDT with a bunch of blocks you're just going to end up pruning anyway.
Mm-hmm.
And having that flexibility really allows you to adapt ZFS to your workload rather than just have to do whatever the vendor wants you to do.
Yeah. I was reminiscing with some of the guys the bad old days, Alan, where we used to have to make those decisions at the time of setting up the system, right? That was like I got to make this decision right now and I'm living with it for the lifetime of the system. But ZFS makes it so convenient to say on the fly, oh yeah, I need a new data set and it's going to be highly compressible data and we're going to change the algorithm to get the maximum compression. Or we're going to encrypt it and pay the penalty for the encryption performance hit, right? But I can make that decision on the fly. I'm not having to go back and say I'm going to have to redo the pool and set up and move data around. No, it's just something you do online.
Yeah, like I remember the old free space fragmentation, where basically you'd decide how to dice up your hard drive, and you'd live with it for a while, and then it turns out, well, I have this new 50 gigabyte file, but I only have 20 gigabytes in that partition and 30 gigabytes in
Hmm.
that partition. And so I'm going to have to move some files and syn-link them back in order
Yeah.
to be able to write this file. And it's like, yeah, with ZFS,
I,
they all pull from the pool of space and give back to it. So
mm,
you just don't have to worry about that.
it's so wonderful not to have to remember how much I allocated to home.
Yep. Yeah. And then obviously ZFS being open source has a lot of value. Starting with no vendor lock-in, right? You can import the pool on a different operating system, or you know, the one we see with hardware RAID all the time is, oh, our controller has died and we can't get exactly the same controller to replace it with. And when we plug it into this different controller, it doesn't recognize the array or something.
Hmm.
ZFS is designed not to care. Like you can switch to a different NDNS CPU and different controllers and a different operating system, and your pool's still there and ready to go. Plus, the fact that it's open source means that if something goes wrong, you have access to the source. If you want to add a feature, you can. If you want to add a feature and you don't have the ability, then you can come talk to us. But the fact that you have those options really makes it compelling versus something you're buying from a vendor where you have no control over anything
Yeah, that's
and
an
no
important
ability to
point.
get your data back out.
I was gonna say it's an important point. If I'll put my business hat on for a second on the TrueNAS side, we talk about the value of open source, but it's about that vendor lock-in too, and who really owns your data. Because if you're beholden to some third party, and again they've limited your access to it or put it on a system where it's not easy to get the data back out, that's not a great situation. So we're big believers in the open source side that it's your data, you own it, you should have access to it by any means necessary because you have to make decisions on where you want to move it, transport it, import it elsewhere, and that's all important. And we want to keep that philosophy in TrueNAS going forward.
Yep. Then obviously there's support on top of the giant open source community of other ZFS users and developers. Obviously, you're getting the expertise from TrueNAS and from Klara if you need it for getting ZFS tuned right, solving whatever problem you might have.
Hmm.
And then lastly, the performance. While ZFS is designed for reliability first, it doesn't give up on performance. Compared to other file systems, it's always doing more work, but often it can do that work more smart. Using compression means if your disk can only write a gigabyte per second, but you compress your data by 50%, you can actually write 2 gigabytes per second, uh, and it's that much faster. And then, same with dedupe and all these other bits that really allow you to take maximum advantage of the hardware you have to get the most out of it. Any closing thoughts before we go on to questions?
No, this is all good stuff. Again, we're covering a lot of ground here, and sometimes I take for granted that we have a kind of a high tune-in factor of people first trying out ZFS and maybe don't quite understand all the nuances and some of the cool stuff it does under the hood. But it really is the file system that we all wanted and didn't know we wanted for so many years. And if you're coming on the TrueNAS side from a Linux background, maybe you haven't had access to this because you've not been in the FreeBSD camp or have run this in Solaris in the past. It really is a game changer. You need to try it out, whether it be on TrueNAS or some other platform. It's important to take a look at what ZFS can provide that you just don't get kind of out of box with most of your typical Linux distributions these days.
So
Okay.
one, I guess, more of a comment that we got from Jeff is, he has a question about a use case he has where he has basically an email ticket archive with 250 million files. So a lot of small text files that probably won't dedupe very well. But in there are 20 million signature logo attachment files,
Hmm.
which probably are, mostly the same ones over and over and over again. Uh,
Hmm.
would that be a good use case for dedupe, or would the overhead of handling the lot of file count maybe not make it worth it?
Yeah, I guess hard to say. It depends also on the
Yeah.
performance of the system. If you're already right at the edge of what you can withstand a performance at too, maybe not.
But yeah, I think, obviously ZFS and compression are going to make those files as small as possible, especially if they're kind of all text being
Hmm.
email archive. And so that'll work well. Um, some
Yeah, the logos
interesting
would be
choices
interesting
there.
though. If
Hmm.
he's got a lot of small like PNGs attached and there's a lot of duplication of those, maybe set a smaller quota to at least get them into the cache and then keep evicting more aggressively the non-dedupable text bytes.
Yeah, and some of that. Uh, in general, dedupe is at the block level, not the file level. So it won't necessarily matter how many files there are. Although, if you have on that data set, I'm guessing you just have the default ZFS record size of 128K. So all the small files will be small, whatever the file size was after compression. And then the PNGs will be the same, but larger. And I'm guessing in most of those, the logos might actually be more of the megabytes than the 230 million other files. So it may, in fact, be worth doing it. It'd be interesting to see on that one.
Yeah. We have a question here, interesting one from Aaron as well, asking about TrueNAS specific question. Is BRT and server-side offload for copies available in TrueNAS Core or Scale? So Scale's where we're going to recommend that, or now we call it the Community Edition or TrueNAS Enterprise. That's where it's the best tested and supported. Pieces of it are available in Core, so it is there, but it's definitely something that we kind of debuted on the Scale side, and it's gotten the most battle testing.
Yeah, and basically BRT is in OpenZFS 2.2, so on any platform that has that, although it is better in 2.3.
Let's see, Rayon here has a question about, with regards to reliability, how often do we perform a scrub? I guess I don't know if we mentioned it again. Maybe people new to ZFS here don't realize you're almost kind of scrubbing inline as you're reading files. You're also always checking the checksum as data is being pulled from disk. But scrub is about really going out and checking those files that haven't been read recently. How often do you want to do that? Well, we can recommend, weekly. You can do monthly, as often as you can afford to, would be my answer.
And I think the default in TrueNAS is once a month, right? The first
Yeah.
Sunday of every month or something like
Yeah.
that. Yeah, the other big thing that a scrub does, like Kris said, ZFS is checking the checksums of files every time you read them, but by default, we don't read the parity unless there's a problem. Whereas a scrub is going to read every file, even ones you don't normally access, and it checks the parity as well to look for, bit rot there and be able to correct it so the parity is correct when a disk dies later. And so scrub is important to the reliability. And yeah, once a month is a good catch-all, but you can adjust it based on your use case.
All right, let's see
I
the
see
other questions
Corey
here.
is asking about using BRT with NFS, especially V3 and V4. I think V4 in particular supports the server-side offload, but I don't know if NFS V3 supports copy file range or not.
Yeah, offhand, I don't recall if V3 does. I know if you're doing it with NFS, for example, with Linux clients, you also have to make sure you're using, the -- ref link flag, and you have the right version of your CP tools installed that'll support that. So that's going to be key. I'd have to go back and look that one up, Alan.
Yeah, me too. Don't have the answer to that one off the top of my head, but and then GCS8 asks, are there any tools for estimating how much metadata or fast dedup and so on, or small blocks you would have on an existing data set, short of using the ZDB tool and trying to figure it out that way? I don't think anybody's built such a tool.
I want to say I've seen some Python scripts floating around that'll go and analyze your data and try and give you an estimate of dedupability, but offhand, I can't think of a good one I'd recommend. Your luck may
Yeah.
vary. If you take a look at GitHub, you might find something.
Yeah, in general, especially now that, as Kris mentioned, the ZFS rewrite feature, where it can actually just apply settings changes to the compression and the dedupe and so on to a data set, it's much easier to try it than it was before. With that feature, you can rewrite data to a data set that doesn't have dedupe and actually get out of dedupe if you need to as well.
All right, Corey has a question here. Are dedupe quotas set at the dataset level or the pool level? For the CI/CD example, a small data set with dedupe quota set and quota set to 0 for large data sets. So we're going to talk
No,
about
the
it
dedupe quota is there's one DDT for the whole pool,
for the whole pool.
so that data written, the same data written to different data sets will dedupe, and so there's not a way to kind of blame any one data set for the size of the dedupe tool or dedupe table. Also, you don't really probably want to ever set the quota to 0. You want to keep it to something that will comfortably fit in the memory cache or on the dedicated NVMe or whatever that you have.
And folks got to remember, again, if you're new to ZFS, ARC is a big deal and also likes to be very RAM hungry. And that's how you get a lot of your read caching performance. So your dedupe cables can compete with that. So make sure you size correctly and allow yourself comfort with some ARC.
Yeah, so we have a question that somebody submitted before here. Sunisa asks, are there any hardware configurations that could increase the performance of fast dedupe, such as using Optane drives did with legacy dedupe? And it's
Hmm.
basically the same. The special dedupe VDEV allows you to keep the written copy of the DDT on a separate device. And so a mirror of NVMEs there will mean that when you do have to read from the disk version of the dedupe table, such as after boot up when you're doing the preload, that device will be much faster, but also means when we're writing out to the DDT, that again, that'll be able to sync out a lot quicker than a spinning hard drive, especially where you're going to be doing a decent number of IOPS, and so hard drives are really bad at IOPS.
Mhm. And I'll answer this one here from Masood, who asks about, are there any good video tutorials training for ZFS and TrueNAS scale? So there's videos everywhere. I think you've heard of this thing called YouTube, and they're all over the place. But on the TrueNAS side specifically, I would give a shout out to our official documentation, which also has links to different videos, lots of how-tos and information. It's a big topic though, so I'm not going to sugarcoat it. There's a lot to learn if you want to get really deep in the weeds about all things storage, ZFS, or TrueNAS. There's a lot there under the hood, but give that a start and go take a look at the TrueNAS documentation, read some of the getting started and how-tos and some of the primers on ZFS. And then as far as video tutorials online, I've seen a whole bunch of them. One thing to keep in mind is the age. Always take a look at the source content because they're talking about ZFS from, 2012 or something. Things may have changed a little bit since then. So it is important. They do tend to have a shelf life.
Yep. Maybe time for one last one here from Lubomir. He asks, can you elaborate more on the data alignment requirements? For example, for data sets with pictures versus data set with ISO files. So if you're using a ZFS data set and putting files on it, then you don't have to worry.
Mhm.
ZFS already is going to know where a file starts and where a file ends. It's in particular when you're using VMs, if you're storing like a VMDK file over NFS, or you're using a ZVol, or whatever, the file system inside the VM will have its native like cluster size
Yeah.
or sector size. There's different names in different file systems, but you want that to align with the record size you set on ZFS on the ZVol or the data set that's backing NFS, so that files will always start on a ZFS record size boundary. That way, ZFS, the start of different files will all line up, and ZFS will be able to detect the same file.
Hmm.
Whereas, if it doesn't, then you're going to have part of one file and part of the file after it in one record, and ZFS, you know, even though you have two identical files, they started in different places in a block, and so ZFS won't see them having the same
Yeah.
hash.
The checksum's different in that case. So there's tutorials
Mhm.
we've done on the TrueNAS side. For example, you have to install Windows with the correct NTFS setup to align that. So that's going to be a very
Exactly.
common use case is running Windows virtualized. So pay attention. Those details matter if you're doing the virtualization side.
Right. Okay. So yeah, if you would like to, evaluate your system and see if dedupe could work for you, or just want to help designing your next ZFS deployment, check out Klara, and we have a QR code here, and you can look at our ZFS performance audit or our design and implementation, and we can help you get up and running.
Excellent. Well, this has been good. Thank you, Alan.
Yes, thank you, Kris, for joining us. Basically, that completes our session. I thank everyone for joining, but especially Kris for rejoining me after all these years. Uh, And if you have any follow-up questions or want to learn more about Klara or ZFS and FreeBSD, definitely reach out to us. And be sure to keep an eye on our webinar page. We do these on a regular basis, and we'll have other interesting topics coming up soon. And we'd love your suggestions on what else you would like to hear about as well. So we'd love to see you again next time. Thanks,
Oh,
everyone.
thanks again.